Part 1, Introduction. Section 1, a land of fire and water, Yellowstone National Park, a land of stark beauty, a place where fire meets ice, towering geysers and vibrant hot springs. Crystal clear rivers cut through lush valleys, snow-capped peaks pierce the sky. Yellowstone is a testament to the raw power of nature. Beneath this beauty lies a sleeping giant, a supervolcano capable of unimaginable destruction. Join us as we journey into the heart of Yellowstone. Discover the secrets of its geothermal wonders. Section 2, the heartbeat of a giant. Beneath Yellowstone's surface lies a massive magma chamber. It fuels the park's geothermal activity. This chamber is the heart of the Yellowstone supervolcano. Geysers erupt with clockwork precision. Hot springs bubble and churn. Mud pots gurgle and spit. These features are windows into the Earth's fiery soul. Scientists monitor these features to track the giant's every breath. Old Faithful, the most famous geyser, erupts every 90 minutes. Its plumes reach heights of over 100 feet. Yellowstone's geothermal marvels remind us of the power beneath our feet. Section 3, a delicate balance. Despite the danger, life in Yellowstone flourishes. Vast herds of bison graze in the valleys. Majestic elk bugle through the forests. Wolves, reintroduced in the 1990s, stalk their prey. Yellowstone is a testament to nature's resilience, but this ecosystem is under constant threat. Climate change, human encroachment, and disease pose challenges. Protecting this natural wonder is paramount. Scientists and conservationists work tirelessly to preserve Yellowstone. They monitor the supervolcano's activity and conduct research. The future of Yellowstone is uncertain, but efforts to protect it must continue. To understand Yellowstone's supervolcano, we must journey back in time. Delve into the geological record where echoes of past eruptions resonate. These echoes whisper tales of unimaginable power. Scientists have pieced together a timeline of Yellowstone's volcanic history. It spans millions of years, marked by periods of slumber and awakening. Each eruption has left its mark on the land. The earliest known eruption occurred about 2.1 million years ago. It ejected over 2,450 cubic kilometers of volcanic material. This eruption created the Huckleberry Ridge Tuff. Yellowstone has experienced 3 super eruptions in its history. These cataclysms reshaped continents and altered the course of life on Earth. The Huckleberry Ridge eruption was a defining moment in Yellowstone's history. It created a massive caldera, forming Yellowstone Lake. The eruption ejected a staggering amount of ash and gas. This material blanketed much of North America. The ashfall had devastating consequences for plant and animal life. The Huckleberry Ridge eruption was a testament to nature's raw power. It was a harbinger of things to come. Following the Huckleberry Ridge eruption, Yellowstone experienced relative quiescence. About 1.3 million years ago, it unleashed another super eruption. This eruption formed the Island Park caldera. It ejected over 280 cubic kilometers of volcanic material. The ashfall disrupted ecosystems and impacted climate patterns. The Island Park caldera eruption demonstrated Yellowstone's cyclical volcanism. It set the stage for the most recent super eruption. Across Yellowstone, the earth breathes. Steam rises from fissures and vents. The air is thick with the scent of sulfur. These exhalations are signs of Yellowstone's restless nature. The magma chamber lies closer to the surface here. This proximity creates a geothermal wonderland. Yellowstone boasts over 10,000 geothermal features. These features are strategically placed along fault lines. They channel geothermal energy to the surface. The geothermal symphony reaches a crescendo in Yellowstone's geyser basins. Superheated water erupts in spectacular fashion. Each geyser has its own rhythm and personality. Mud pots gurgle and spit, resembling primordial ooze. Fumaroles hiss and roar, releasing steam and gases. Hot springs shimmer in shades of turquoise, emerald, and sapphire. These features are windows into the Earth's inner workings. Scientists study them to understand the processes beneath the surface. The geothermal symphony is a delicate balance. Among Yellowstone's geothermal wonders, geysers reign supreme. These fountains of boiling water erupt with explosive force. Old Faithful, the park's most famous geyser, erupts every 90 minutes. Its plumes reach heights of over 100 feet. Not all geysers are as predictable as Old Faithful. Some erupt sporadically, influenced by various factors. These unpredictable geysers are a reminder of the raw power beneath the surface. Scientists study the timing and intensity of eruptions. Each eruption provides valuable clues about the forces at play.
The monitoring efforts at Yellowstone are not merely an academic exercise. They are a vital part of a comprehensive early warning system designed to alert authorities and the public in the event of an impending eruption.
This system, a testament to the collaborative efforts of scientists, emergency managers, and government agencies, is designed to minimize the impact of a volcanic event.
The USGS has developed a volcanic alert level system to communicate the current threat level of volcanoes in the United States. This system, ranging from normal, green, to eruption imminent or in progress, red, provides a standardized way to inform the public about volcanic activity.
In the event of increased unrest at Yellowstone, the alert level will be raised accordingly, triggering a cascade of pre-planned responses.
These responses would include increased monitoring and analysis, public information campaigns, and, if necessary, evacuations of areas potentially at risk.
The National Park Service, in coordination with state and local authorities, has developed evacuation plans for Yellowstone, outlining routes and procedures for safely removing visitors and residents from harm's way.
The early warning system is a testament to our ability to harness science and technology to mitigate natural hazards. While we cannot prevent a volcanic eruption, we can take steps to minimize its impact.
The watchful eyes of the scientists at YVO, combined with the preparedness efforts of emergency managers, provide a vital line of defense against the sleeping giant's fiery breath. The consequences of a super eruption at Yellowstone, well, they are difficult to comprehend. Scientists, using sophisticated computer models and drawing upon evidence from past eruptions, paint a grim picture of the immediate aftermath.
The blast itself would be catastrophic, leveling everything within a radius of hundreds of miles. Pyroclastic flows, avalanches of superheated gas and ash would race across the landscape at speeds exceeding 500 miles per hour, incinerating everything in their path.
The ashfall would be even more widespread, blanketing much of North America in a thick layer of volcanic debris. The weight of the ash would collapse roofs, clog engines, and short out power grids. Air travel would grind to a halt as the abrasive ash would damage aircraft engines. Agriculture would be decimated as crops would be buried and livestock would suffocate.
The immediate impact would be devastating, but the long-term consequences would be even more far-reaching. The ash cloud would block sunlight, causing global temperatures to plummet. This volcanic winter could last for years, disrupting growing seasons, leading to widespread crop failures, and triggering a global famine.
The economic impact would be staggering. The United States, with its heartland buried in ash, would face an unprecedented economic crisis. Global trade would be disrupted as supply chains would be severed and economies would be thrown into turmoil. The world as we know it would be forever changed. The eruption of a supervolcano like Yellowstone would be a global event, its impacts reverberating across continents and affecting every aspect of human civilization. The ash cloud carried by prevailing winds would circle the globe, casting a veil over the planet and disrupting weather patterns for years to come.
The injection of sulfur dioxide into the stratosphere would react with water vapor to form sulfate aerosols. These aerosols would reflect sunlight back into space, causing a global cooling effect. While the exact magnitude of this cooling is difficult to predict, it is estimated that global temperatures could drop by several degrees Celsius, leading to a prolonged period of colder than average temperatures and potentially triggering a mini ice age.
The environmental consequences would be equally severe. Acid rain, formed from the sulfur dioxide in the atmosphere, would contaminate water supplies, damage forests, and harm aquatic life. The ozone layer, already weakened by human activity, would be further depleted, allowing harmful ultraviolet radiation to reach the Earth's surface.
The social and political ramifications of a Yellowstone supereruption are almost too daunting to contemplate. Mass migrations, triggered by food shortages and economic collapse, would strain resources and potentially lead to conflict. Governments would struggle to maintain order and provide for their citizens in the face of such a cataclysmic event. The very fabric of society would be tested.
The fiery heart of Yellowstone, though potentially destructive, plays a paradoxical role in nurturing the park's abundant wildlife. The geothermal features, born from the supervolcano's heat, create a mosaic of habitats that support a remarkable diversity of life. This unlikely alliance between fire and life is a testament to nature's adaptability and resilience.
The warmth emanating from the geothermal areas creates microclimates that allow certain plant species to thrive year-round. These plants, in turn, provide a vital food source for herbivores, especially during the harsh winter months when other food sources are scarce. The presence of hot springs and geysers also creates open, snow-free areas where animals can congregate for warmth and access to water.
The geothermal features also influence the distribution and behavior of some of Yellowstone's most iconic animals. For example, bison, drawn to the warmth of the geothermal areas, often graze in meadows near geysers and hot springs. This behavior, while beneficial during the winter, can also expose them to danger, as the ground around geothermal features can be unstable and prone to collapse.
The reintroduction of wolves to Yellowstone in the 1990s further illustrates the interconnectedness of the park's geology and wildlife. Wolves, as apex predators, have had a profound impact on the ecosystem, not only by controlling elk populations, but also by influencing their behavior. Elk, now wary of wolf predation, are less likely to overgraze in riparian areas near geothermal features, allowing these sensitive habitats to recover.
The geology-wildlife connection in Yellowstone is a delicate balance. The same geothermal features that provide warmth and sustenance to wildlife can also pose a threat, as the ground around them can be unstable and prone to collapse. Understanding this complex relationship is essential for managing and protecting this unique ecosystem for generations to come.
Yellowstone stands as a testament to the awe-inspiring power of nature, both its beauty and its potential for destruction. The sleeping giant beneath the surface, a force of creation and devastation, has shaped a landscape unlike any other. Its fiery breath, while capable of unimaginable destruction, also sustains a remarkable diversity of life.
The geysers, hot springs, and mud pots, each a window into the Earth's fiery soul, serve as a constant reminder of the immense forces at play.
Yellowstone is a place of constant change, a delicate dance between creation and destruction. The watchful eyes of scientists, constantly monitoring the giant's every move, provide a sense of security, but the inherent unpredictability of nature reminds us that we are but temporary visitors in this ancient landscape.
As we've journeyed through Yellowstone's geothermal wonders and witnessed its abundance of life, we've gained a deeper appreciation for the delicate balance that exists in this unique ecosystem.
The story of Yellowstone is a reminder of our planet's power, beauty, and fragility. It is a call to action to protect and preserve this natural wonder for generations to come.
The future of Yellowstone remains uncertain. The sleeping giant may slumber for another 1,000 years, or it may awaken sooner, forever altering the landscape and leaving its mark on human history.
But one thing is certain. Yellowstone will continue to captivate our imaginations, reminding us of the awe-inspiring power of the natural world and the importance of respecting and safeguarding our planet's most precious treasures.